Section 3, Chapter 11, we're doing limiting reactants. Okay, a limiting reactant limits the extent of the reaction and determines the amount of product formed. So think about the word. It limits how much you can produce because it's a smaller amount than maybe you have of the other one. Okay. The other one's going to be called an excess reactant because when you make your products, you're going to have excess of that reactant left over.
All right, so our limiting reactants used up first. Excess would be just sitting there waiting it to get more of the other reactants so that it could make more product.
Right.
Okay.
Okay, so there's big calculations that you can do to determine limiting reactants, but we're not going to go there. We're only going to do the mole ratios, and then we'll be able to see which one is our limiting reactant based on the mole ratio. So if you balance your equation, like we did here, S8 plus 4Cl2 produces 4S2Cl2, you are going to compare your mole ratio of S8 to your moles of Cl2. So you have 1 mole of S8 and 4 moles of Cl2.
Okay.
Okay. Let's say that you have 4 moles of S8 and 12 moles of Cl2. You're going to figure out which one is the limiting reactant. Well, let's reduce 4 and 12. How do we want to do that?
What are we going to? Are we going to reduce?
Well, we want S8 to be a 1 because it has less than chlorine.
So, so then we're going to divide the 12 by 4?
Sure.
All right, that'll give me 1 mole of S8.
Oh, no.
Precursor.
Yeah.
All right, so we got 1 mole of S8, and then the 12 moles of the Cl2 would be divided by 4. That'll give us 3. So then we'd have a 1 to 3 ratio with those.
Yes. So you're going to have 1 mole of S8 to 3 moles, just like she said.
Okay. Are we going to then compare what we started with in our balanced equation? Okay.
So up here, notice we started with, for every 1 mole, you need 4 moles of Cl2. Well, right now we only have 1 mole of S8,
okay. So
which
that's
is the same as here.
Yeah.
But we only have 3 moles of Cl2. But up here we need 4 moles of Cl2.
So we don't have enough for that to be equal.
Right. We don't have enough of this Cl2.
So that's our limiting reactant because it's the lower amount.
So limiting reactant, or LR, is going to be Cl2.
Okay. And then that makes our S8 our excess. Okay.
In class, we're going to do a lab, and you will have to compare your mole ratios and figure out, based on your theoretical mole ratio, which is this 1 to 4 from your reaction, you're going to have to compare your actual values to your theoretical and determine which one's limiting based off of that.
Okay.
Okay, so I like this analogy because I like brownies. But if you think about it, if you buy 2 boxes of brownies and you have a dozen eggs, think about which one's going to be your limiting reactant. Your brownie mixes probably only take 2 eggs each. So your brownies are going to be used up before all of your eggs are used up.
So my brownies are my limiting, and my eggs are excess because I have more eggs left over than what I actually needed.
Right. Because look at the end, you have 2 boxes, or you only have 2 batches of brownies, but you still have 8 eggs left. So that's your excess reactant.
I like brownies. I like this example.
Now let's look at one that's more chemistry related. If you have hydrogen and oxygen react, okay, so your hydrogens are the little gray compounds and your oxygen are the red ones. Notice that they're reacting, they're forming water. Well, look in your product box, you've still got some
oxygens left.
Oxygens that are left over.
That didn't pair up.
Right. So all of your hydrogens were already paired up. There's no more hydrogens for the oxygens to use. So your oxygen is excess and your hydrogen is limiting.
Okay. Because limiting was used up. I got this.
Okay. So that's the gist of limiting reactants
Who's
and
used up?
excess
Who's
reactants.
left over?
Okay. So you'll do a lab in class, and that's about the extent that you need to know.
Yeah, but you'll be doing problems to identify.
Oh yeah.
You'll be good.
Okay, let's move on to section 4.
Yay! Percent
yield. It's really similar to all the other percentages you've done.
Let's hope you know how to do a percent by now.
Okay, your theoretical yield is the maximum amount of product that can be produced from a given amount of reactant.
Okay.
So, if I ask you to do a calculation, That's your theoretical yield.
Theoretically, your math is perfect.
So if your reaction reacted 100%,
Ooh.
that's what your theoretical yield would equal.
Yeah.
It really never happens.
Which is why you get your actual.
Your actual yield is the amount of product produced when the chemical reaction is carried out in an experiment. There's always a small amount of error, sometimes a large amount of error.
Sometimes, most often, you guys make a lot of errors.
So even at the college level, you make errors, but your actual is what you get in an experiment.
All right.
So your calculation for percent yield, you're basically seeing how efficient was your reaction. Did you only produce 70% of what you said? Did you only produce 35% of what you said? But the way that you determine it is percent yield equals actual yield divided by theoretical, multiplied by 100.
I think of it alphabetical order, A over T. A comes first, so A goes on top.
Yes. So write this in your notes. If you have to pause this, go for it.
Let's do a problem.
Okay,
Woohoo!
what do we have to do first?
Always
Sandra?
look and make sure it's balanced.
Okay, one ZN, one ZN, one I, two I's. We're good. Determine the theoretical yield of zinc iodide if 1.92 moles of zinc is used.
Okay.
Whoa.
So we got to change a mole into grams.
Okay, we can do that. 1.912 moles of ZN. What do we need to do?
Well, first thing we need to do is make sure that it's in the same unit that we want our answer in, and they want the answer in zinc iodine. They gave us zinc, so we've got to use our mole ratio to move between the two.
Yep.
So our mole ratio is 1 to 1. That's nice and easy.
Yeah, that was nice this
Yeah,
time.
we're nice.
This time.
All right, now we've got our mole in, and we're going to multiply by our molar mass of zinc iodine, which is 192.
Okay, notice what
And-
cancels.
yep,
Moles
cancel
of zinc,
through.
moles
Do,
of zinc,
do,
moles of zinc
do,
iodide, moles of zinc
do.
iodide. What do we
Final
got?
calculation is 367.1 gram.
Of zinc
Ni2.
iodide 2. Or sorry, zinc iodide.
All right, so that's our theoretical. Theoretical is the math. So in a perfect world, if we did everything with no error, you should make 367.1 grams of zinc iodide.
Okay,
However,
you're going to use this math that you just did in your next problem. So
Okay.
don't just forget what you did. It's written right above.
okay,
All right, determine the percent yield if 315.6 grams of the product is recovered. So if you see something like recovered or obtained, that's going to be your actual yield.
that's what you made.
And notice this says when 1.912 moles of zinc is used. Well, we just did 1.912 moles of zinc. So use what you've had before. That's your theoretical. In this problem, we give you your actual. So
All right, so A over T, so 315.6 grams divided by our 367.1 times 100, and we made 85.97%.
that's pretty good.
I think so too.
Zinc iodide?
Yep.
Okay.
Done.
All right, so in labs, we'll definitely have you do this.
Yep.
Or we may give you a problem like this.
Oh yeah, you'll see a lot.
All right, that is all of chapter 11. Make sure that you know how to do mole ratios. Make sure you're balancing your equations. You can do mole to mole. You can do mole to mass. You can do mass to mass.
Limiting
missing?
reactant
Limiting excess reactants.
and percent yield.
Percent yield.
Sounds like a lot, but it's really not that hard. But you can do this. You can do this. Don't be frightened by everybody else that says
Says chapter
stoichiometry
11 is terrible.
is the death of you. You're going to die. It's not that bad.
Have fun.